Hi, today we're gonna go over standard deviation. So, standard deviation is a statistical measure that shows how much data values deviate from the mean of a data set. Uh, Basically, it tells us how spread out the data is. For example, the more spread out the data is, the larger the standard deviation. Okay. Here's the formula for standard deviation. I know it looks a little bit complicated, but I'm gonna do some examples to show you how it works. There's a symbol, there's a couple new symbols there, okay? One of them we actually know how to calculate it, we just didn't use that symbol. The X bar. X bar is actually the mean, and that's what we did last week. So that's when you add all the numbers up and divide it by how many numbers you have. Okay? This symbol here is capital sigma. This symbol, this symbol just means to sum, basically to add. Okay. And then the last symbol, that's the actual symbol for standard deviation. That's a lowercase theta. I'm sorry, lowercase sigma. And this is called, this is the standard deviation. So those are the three new symbols, and I'll show you how they work in a bit. So let's look at this example here. So below are the test scores of three students. So Sue got 75, 65, 73, 67, 71, 69. Sally got all 70s. And then Sandy got a 90, then a 50, 82, 58, 79, 61. Okay. Before we continue, I'm curious to know what's the average score for these students or the mean. So remember to find the mean. We're going to add up all the numbers and divide it by how many numbers we have. In this case, we have 6 numbers. So this is just a quick review of what we did last week. So I'm going to use the calculator. Okay, these numbers add up to 420. Divide that by 6 and 70. So Sue's average was 70. Now for Sally, her average, you take all the 70s, you add those up first. And I think you could guess what this is because 470, I mean, sorry, 70 plus 70 plus 70 plus 7, that's 420 divided by 6 is also 7. Well, that makes sense if she all of her scores are 70, then her average has to be 70. And then finally for Sandy, let's add these numbers up. So all these numbers also add up to 420. Divide that by 6 and you get 70. So Sue, Sally, and Sandy, the three of the students, have an average score of 70. Okay? But remember, this lesson is about standard deviation. Just a quick reminder, basically it tells us how spread out the data is. So here's the first question to think about. Which of the students is going to have the highest standard deviation and why? So basically you want to know which student has their test score spread out the most. And that student is Sandy because she has high and low scores. Okay, it's spread out the most. Now I'm going to show you how to calculate it in a bit. And then the second question, what will the standard deviation for Sally scores be? Okay, so Sally's has all 70s. So how spread is that? Well, it didn't spread at all. So actually, this is going to have a standard deviation of 0 because all her scores are the same. Okay, so this is basically the purpose of standard deviation, how spread out or not the data is. Now I'm actually going to show you how to calculate this now. Okay, so we're going to calculate the actual number for Sue's standard deviation. So I'm going to do that down here. And I'm going to go ahead and write the formula down here. So I don't have to scroll up and down. Okay. There's a lot of little computations you're going to do when doing standard deviation. So you're going to actually organize your data into a table. So I'm going to take all the x values and I'm going to write them in a list. Okay, and for Sue, her scores were 75, 65, 73, 67, 71, and 69. Okay, those are her scores. Okay. And then for each one of these numbers, oh, I forgot the little bar up here in the formula. You're going to subtract the actual number. You're going to subtract the mean from each one of those numbers. And remember, the mean is 70. That's what we calculated up here. So we know the mean is 70. So each one of these numbers, you're going to subtract 70. So 75 minus 70. 65 minus 70. It's negative 5. 73 minus 70. 67 minus 70, that's negative 3. 71 minus 70 is 1. And then 69 minus 70 is negative 1. Okay. Next, we're going to square that previous number. So whatever we got from x minus x bar, we're actually going to square it. So these numbers here, we're going to square. Okay. So 5 squared is 25. Negative 5 squared is 25. 3 squared is 9. Negative 3 squared is 9. 1 squared is 1. Negative 1 squared is 1. Okay. Next, we're going to find the sum. All right, so we have another calculator. I mean, another color. So you see this that I boxed in green here? This means the sum of all the x minus, oops, x bar squares. Okay, so that's the sum of all of the x minus x bar squares. So we have to add all these numbers up. That's what that means. Okay, now write it down here. So the sum of all the x minus x bar squares is, well, it's 25 plus 25 plus 9 plus 9 plus 1 plus 1. Um, that is 70. Okay, so all these numbers add up to 70. Now we could finally actually use the formula. Okay, so it's going to be the square root. The sum of all the numbers is 70. And then divided by n. N is how many numbers we have. We have 6 numbers. Okay. So using the calculator, the square root of 70 divided by 6 is 3.42. You just round it to 2 decimal places. So this is an example of Sue's standard deviation. Let's do another one so we could get a little bit more practice. So next, I'm going to find the standard deviation of Sandy. So I'll do it down here. Okay. So let's start by making the list of her test scores. 90, 50, 82, 58, 79, and 61. Okay. Next, we're going to subtract the mean from each one of these numbers. Okay. So subtract 70. 90 minus 70 is 20. 50 minus 70 is negative 20. 82 minus 70 is 12. 58 minus 70 is negative 12. 79 minus 70 is 9. And 61 minus 70 is negative 9. Next, you're going to square that previous number. So we're going to square all of these. So 20 squared is 400. Negative 20 squared is 400. 12 squared is 144. Negative 12 squared is 144. 9 squared is 81. And negative 9 squared is also 81. Okay. Next, you're going to sum all of the x minus the mean squares. Okay, so add all these numbers up. 400 plus 400 plus 144 plus 144 plus 81 plus 81. That's 1,250. Okay. Now, let me copy the formula over. Okay, so the standard deviation is the square root of the number we just found, 1,250, divided by how many numbers we have? We have 6 numbers. So use your calculator to calculate this. So that standard deviation is 14.4 approximately. 43, 2 decimal places. Okay, so Sandy's is 14.43. Sue's is 3.42. Notice that Sandy's scores, like we said previously, are way more spread out than Sue's scores. That's why the numbers, the standard deviations are different. That's why Sandy's standard deviation is much bigger. Okay. Last thing I want to show you. Oh, okay. We predicted that Sally's standard deviation was going to be 0. So let me just show you what that looks like if we actually try to calculate it out. Okay, so Sally's standard deviation. Okay, so she had 70 for all of her scores. 3, 4, 5, 6. X minus X bar. The average is 70. So 70 minus 70, 0. And then we're going to square that number. So 0 squared is also 0. And then we need the sum. So if I add up all these numbers, the sum is 0. So the standard deviation so the sum we just said is 0, and we have 6 numbers, but 0 divided by 6 is also 0, and the square root of 0 is 0. So I'm just showing you why the standard deviation is 0 if we calculate it the long way. And that's it for the examples.